Okay, this is ITS 128, and today we're starting Chapter 7. So let me share my screen. There we go. And I'm going to put this thing over here. All right, so it's November 1st, this day. First day of Chapter 7, and this is arrays and lists. This is really the last huge conceptual thing that you'll learn in programming. After that, it's just finding better, more convenient ways of doing things and modularizing and connecting to databases and so on. So if we go to let me see if I have some slides here. Chapter 7. I'm gonna pull those down, and I'm also gonna go. I'm going to switch to Edge. I try to remember to do that. Because with Edge, I can write on the screen. So if we go to, let's go to the textbook, take a peek at Chapter 7. Let's go down to where Chapter 7 might start. It's right here. Okay, so so today we're going to cover probably up to working with files and arrays. I think we'll probably get a tier here. I don't know, maybe we'll. The concept of an array is quite simple. Let me see. I'm going to pull up the slides. Probably better to start with slides. All right, so we're going to talk about the difference between a value type and a reference type, and we've talked a little bit about that when we were talking about passing parameters into methods and out again. And we have to emphasize these concepts here because arrays are always passed by reference. They're never passed by value. You never pass an entire, well, you don't know what an entire array is, but it's a collection of values, all of the same type. And it's one array name, or it's one name, but then there's a subscript which says which one it is. So the difference between the data types fall basically into two categories: value types and reference types. A variable can hold a value, like an integer or a string, but a variable can also be a reference to another variable. So it's like an address to another variable. So you can have an address to a string or a reference to a string, and the string, for example, could be really long. So the variable that holds the string has to be really long. But if you have a reference variable that refers to the string, it doesn't need to be long. It only needs to be long enough to say where the string is in memory. When you declare a value type variable, which is all we've been doing, the compiler actually allocates a chunk of memory that is big enough for the variable, and the value type actually holds the data. Whereas with the reference type, you use two things. First of all, you use an object, which could be just a variable, could be just a value variable, that is created in memory, and then you create another variable that references that thing. And the reason we say object is because, as you know, in C#, a variable is sort of a unique type of object where all it can hold is one value. But there's variables that can hold multiple values, and those are called arrays. And then there are objects which there are also things that can hold methods also, like classes. They hold variables. With a class, you can store. If you create an object that's a type of a class, you can store an integer just like an integer variable, but you can also store other stuff, and it can also provide you methods to operate on its data. So when a variable is created in memory, that's a reference. It just holds the so-called address of a particular object, and the object is the thing that stores the actual data. But the reason this is important is because when we get to, because now we're talking about arrays, and you can have an array called names, and that single array can hold 1 billion names. And so, name 1, name 2, name 3, all the way up to name 1 billion. And so that's going to be a really huge thing. And so if you want to pass that to a method to, say you want to, sort that, or say you want to figure out if a certain name is in that array, and you don't want to do it all in the main code, you want to pass it off to a method to do it. Well, you're going to pass the array as a parameter, but you're not going to pass the whole entire array, because that'd be this huge thing that you'd be passing. You only pass a reference to the array, and then inside the method actually accesses the exact same array as the caller does. There's kind of an analogy of a kite. Kite is the object, and the spool of string is what holds the kite to the reference. We didn't cover the random class, and I think we're going to get to it in this chapter. But I see now one reason for actually introducing that in the 5th chapter was to more introduce you to the concept of a class like this, where you can create an instance of a random class, and with the random class, it's got these methods in there to produce a sequence of random numbers and so on. And so in this case, you're declaring this is a reference. It's a variable. It's an example of a random class where you define a reference called random, and it's a reference to a random type or a random object. And this creates the new object. It's a random object, and it's got its own memory space, because it's going to store it's going to have its own data and keep track of its own sequence of random numbers that it's sending you. And so this is how you would sort of illustrate that, where you're declaring this thing called rand, and what this thing is it's a reference to a random object, and this is the thing that you use to generate the sequence of random numbers. So an array allows you to store a group of items of the same data type all together in memory. Processing a large number of items in an array is usually easier than processing a large number of items stored in separate variables. So let's say because the variable just holds one type of data, and each variable must be declared separately. Here you're declaring 2 variables, and they need to. So it's not ideal for storing lists. Arrays are reference type objects. to create an array, you need to first declare the object, which is going to store the array. And then, first you declare here, we're declaring the reference to the object. And then we actually create the object, and we associate that object with the reference variable. For those of you that have used arrays already, this is just a really academic way of explaining this, and it's probably more confusing than not. But if you haven't seen arrays at all, and you're learning C# for the first time, and you're learning programming for the first time, then of course this is a good way of learning it, because you're learning the foundation, the foundation of why things are the way they are before we actually use them. So here's an example of declaring the reference to the array, declaring the reference, and so you're saying that this variable called numbers array, it's going to be a reference to an integer array. So instead of saying int numbers array, you say int and then the brackets. The brackets are gonna be what we use for the subscripts, as you see down here. So first you declare the existence of the reference, and then you declare the object itself. So this is the object itself. This is like the generic format. So in this example here, we've declared this new variable. We haven't assigned it anything. It's a so-called null variable, and it's a variable that's gonna, once it's assigned to something, you can treat that thing that it's assigned to like an integer array, or as an integer array. And so that's what, so it's almost like it doesn't matter what you really connect it to. It's, once you do this, it's an integer array. So here, so first we've declared this reference, and then here we are now creating the actual object, and we're going to assign the reference to it. And the actual object is going to be a new integer array that can hold 6 integers. That's that's what this notation depicts or denotes. So so here's the example. Here's what we just, this and this is, first we declare the variable type, just like declaring a var, just like declaring any other kind of variable type, like a string or integer or a decimal or a double or whatever. And then we're just assigning it the actual, this actually assigns the reference. So you're assigning this thing here, the reference of to this integer array. And of course you can combine it into one statement, just like we do when we declare integers. Sometimes we declare integers, and right there on the same line we assign it a value. We initialize it a value. It's the same kind of thing that we're doing here. We're declaring a reference to an integer array, and we're actually assigning it to the integer array. Now the contents of the array is still, 0. It's actually 0, I think, or unknown. But this is only assigning the reference. You can assign actual values to the six values. That's done differently. We're probably going to get to that here. We're not there yet. So you can declare arrays of any data type. Here you're declaring you're creating a reference to a double array called temperatures, and here you're creating that double array, and oh, by the way, you're going to have it be 100. It can hold up to 100 temperatures, different double numbers in this double array. It can hold 100 of them. Here it's a decimal type, and you can store up to 50 of those decimal types. And here's a string type, and it can store up to 1,200 of those strings. Okay, so this is a size declarator. This is the size declarator. An array's size declarator must be a positive integer and can be a literal value. So you can see, you can do it this way where you declare, first you define a constant integer called size, and it's a hardwired number into the code of the binary file that's executed. And then, so then you can use size. So this declares a reference called numbers array, and it references an integer array that has six elements. And it's preferred practice to use a named constant, or you might use the length property of the array. We'll get to that. But if you're not going to use the length property of the array, or using it to initialize or whatever, it's preferred to use a constant. Why? Because you reference the size of the array lots of places, like when you have a for loop and you want to loop through all the elements of the array, or you have something else and you want to loop through all the elements of an array. You want to just have that number without having to remember what you defined it as. And then also, if you want to change it to something later, you only have to change it in one place. The storage locations in an array are known as elements. I've used that term already. In memory, an array's elements are located in consecutive memory locations. Each element in an array is assigned a unique number known as a subscript. The reason it's assigned consecutive memory locations because there's actually hardware built into to the processor. They're called index registers, and they can really fast increment, one defined step at a time, really fast through memory. And so when you're doing something like you want to clear out an array, or you want to initialize an array or something, or you want to copy one array to another, the special index registers inside the microprocessors make it really fast, because every programming language has arrays in it. Each element is in an array is assigned a unique number known as a subscript. Subscripts are used to identify specific elements in arrays. Subscripts start with 0, and they go all the way up to the size of the array. And so the index subscript, since you start counting at 0, if an array's got 10 elements, you number them 0 through 9. So this is an example of you have declared in a numbers array, which is a reference to an integer array of size 5. And this is what it looks like pictorially. You've got this variable here, and it references. Now, this set of 5 memory locations, this set of 5 memory locations are, data, I guess that's what they're called, memory locations, can be one place, and it probably is as far away. It's in the data segment of the processor memory, and then this is way someplace else, and so this is just an address. This is the address of this memory location, basically. All right. So here's code. Here's code how we can access each individual element by their subscript and assign each value to 20. And so by the way, you refer to the third element by the subscript of 2, and this is either you can use this on the right side of an assignment statement, or as it is up here, it's on the left side of an assignment statement. You're assigning a value to it, or this can be in an expression. It can be in an expression. It doesn't have an example of that, does it? Okay, on to other ways of initializing arrays. Okay, you remember I said you can even combine assigning the values of the array all in the same declarative statement for declaring the array, declaring what's going to be referred to as, what the variable name is going to be referred to as, the size of it, the type of it, and even values. And so this is all that in one line. Okay. Now this here says, well, I know the size of my array is going to be 5. So I'm going to declare this array of size 5, and I'm going to put 5 numbers in there, and that's how it's going to assign it. Or you can say, well, you know, I can't count up to 5. I can only count up to 3. So I'm just going to put them in there, and I'm going to let the compiler figure out that it's a 5 that should go in there. And so you can do that, and it'll work. And here you can even leave off the this new int, because I guess it's redundant. The int is certainly redundant. So you can just even do it this way. So this is the first time that nums array, the variable name, the word nums array appears in the program, and you're saying it's a reference to an integer array, and these are the values of the integer array. And oh, by the way, compiler, you figure out what the size of the array is. They all three produce the same results. So here's a way that you can, this is one reason of why you want to know what the size, have the size be a constant. And here, so here you're going to assign all the values of the array, the value 99. So you want to, so once you start out, you want to have all the values of the array be 99. Maybe you're going to, there's reasons for doing that. We'll probably use them, but later. But you might do something like that because you're storing a bunch of temperatures, and you want to initialize the temperature as to something which you know won't be the temperature, and you know the temperature is never going to get up to 99 degrees. So you make them all 99, and then you say take off and start recording the temperatures, and then when you look at the array, you can tell if ones have been recorded and the ones that haven't, because they're still 99. That's an example. Anyway, so you're using a for loop, and this is how you would do a for loop. You remember it goes from 0 to the size minus 1. So if it's 3, it's going to be 0, 1, 2, and it loops like this. So here, first of all, you're saying you're declaring a size constant equal to 3. And then here you are defining a reference to an array, an integer array, by the way. And on this right side here, you are creating the array, the integer array, and you're making it 3 elements long. And this is a for loop which indexes from 0 to 2, 0 to 3 minus 1. Or just 0 to 2, and it assigns each time, incrementing the index value each time by 1, and this is where you reference it. It's on the left side of an assignment statement. And as you might expect, if you go over the bounds, if you try to reference an element in an array that does not exist, it will throw an exception, as they say. An exception will be thrown, and of course you can test that. So you know, you put that, if you want, you can put that in a try catch, but first of all, you should just be smart enough not to ever do this. But you know, should for some reason let's say you set some size. Let's say you're reading in a bunch of data, and you know you're never going to read in more than 1,000. And so but you want to put in a try catch just in case for some odd reason it's reading in more than 1,000, or maybe you're still debugging your program and you want to catch errors because you want to catch bugs in your program. You might put the whole thing in a try catch, and then in the catch block, you can refer to the type of error that caused the exception and know that that's why the exception was thrown. Okay, so there's this length property that I mentioned earlier, and that is, you know, it's a property of the array of the variable, the array variable. It's actually an array reference. It's an array variable, which is a reference to the actual array. And that property is the number of elements in the array, or the length of the array. So temperatures, here we know temperatures is going to be 25 because we declared it as a 25. And then here we can just display out, remember it's actually an integer, so you got to convert it to a string before you display it out in a message box. But where it's useful is you can use that as the upper bounds for looping through the array. See, and so you don't really need. So that's, you know, if you there's going to be a lot of cases where you aren't going to want to programmatically keep track of the length of an array. You want to do something, fill it up, and then you know what the length is. So you can just use the property. There's a variation of the for loop, and it's the for each loop. And you can use the for each loop with arrays, or you can use the for each loop with other collections, and we'll get to that. So here it's just a way to loop through all the elements of the array, starting with the first one, and you want to be able to read them out and use them on the right side of an assignment statement. You cannot use a for each loop to assign new values to an array. So you can't use a for each loop if you want to use the you know, each element at a time, or each object at a time as on the left side of the assignment statement, only the right side. But when you really think about it, you wouldn't think to use a for each if you're going to actually assign values, it turns out. So here's an example of one way of using a for each. Let's say you declare a reference to an integer array called numbers, and you load it up with 3 integer values, and then you want to loop through them and just display them out. Say, okay, so here's how you do this. The array is numbers, N-U-M-B-E-R-S. So this numbers has got like 3 of them. It's got you can use the word collection. It's got a collection of them. It's got an array of them. There's 3 of them in there. This for each is going to loop through all 3, starting with the first one up to the last one. But how do you actually refer to one of the elements? Well, you say, okay, I'm going to introduce a variable called an integer variable. It's just an integer variable called val. And each time through this loop, you can refer to the number as val. Simply val, not val, left left square bracket, digit, right square bracket, but just val, just an integer value. And so here's how you do that. So here you are listing out, you are just displaying out these numbers one at a time. And so here we're saying take whatever val is this time around. The first time around it's going to be 3. The second time around it'll be 6. The third time around it'll be 9. Take whatever it is this time around, convert it to a string, and display it out as a message. Here we're using we're working with files and arrays, where we are loading up an array with the contents of a file. Is that what we're doing? No, we're writing out the contents of an array into a file. This book demonstrates how to write an array's contents to a file. Here's the code. This book, this bullet, here's how's that. This bullet demonstrates how to write an array's contents to a file. So, so here we declare an array called numbers, got 5 numbers in them. Here we're declaring another variable, this is a reference to a Steam writer object. And this actually, let's see, this is a reference to a Steam writer, it's not a stream writer object. And this assigns the reference, So the reference is to a file called values.txt, and we're going to open that file in a way as to overwrite whatever's in there if there is anything in there. So we're going to open it up from the beginning. We're going to write to it. If this were append text, then we would open it up from the end and we would be adding stuff to the end. But if great text, we're opening up from the beginning. Whatever's there, if there was anything there, is gone. And then we do go through this loop, and we loop through all the numbers, 10, 20, 30, 40, 50, because that's what the length property tells us. And this writes them out one at a time, one line at a time. Closes it. Okay, so this is how you write out all the values of an array. Gee, it sounds like it'd be good to have that in an assignment. Well, we'll get to that. Here's one that reads values from an array. Okay, so here we're defining a so this is how you read it in. I guess we're only going to read 5 of them. We're going to read at most 5. So we have this, we declare this new, and they're going to be numbers. So we declare this new array called numbers. It's an integer array, and it can have up to 5 elements in it. It's got 5 elements in it. Okay, it's got 5 elements in it. And then we're going to declare a reference to a stream reader object, and this assigns the actual this opens up this stream reader object using the open text method, which means we're opening up to read from the beginning. This is the name of the file. And so now we can use the methods and properties of a stream reader variable by referencing this using the name input file. Okay, so here we're looping, and we initialize the index at 0, and here we incremented it. So we're looping through index 0, 1, 2, 3, 4, whatever, up to the length of the array, which means it's 5. And the input file has not reached an end of file, an end of stream, an end of Steam. No. So so this is an and. So they both have to be true for you to continue on. So what this means is if there's only 3, let's see, for example, if there's only 3 integers in this file that we're reading in and loading up into this array of numbers, there's only 3 of them in there, then it will end after 3 because of this. Can I write on this thing? Well, because of index less than or equal to numbers.length. So once it hits 2, and then it increments one more time, it comes back around, it's 3. 3 is too much, so it skips out and we're done. Or we reach the end of file. No, I'm sorry. 3 is not too much. But what happens is the end of file happens. And so even though the index is not less than 5, see 5 is what numbers length is, even though that, the fact that the input, that it's not, that the input file is at end of string. This is now true, which makes this thing false, which means this whole thing is false, which means it skips out. So anyway, you understand that. And then passing an array as an argument. I mentioned this. You can pass it when you pass it this way. You're passing a reference to the array. Okay, so up here you define a reference to an array called people, and it's a string. And the array is a string array. So people is a reference to a string array. And oh, by the way, this is what the a string array is. The string array has got 4 elements, and oh, by the way, each element only has exactly 4 characters. That's kind of coincidental. And then it calls this method called show people. Well, what's this method called show people? It's something we've defined here. Can I guess there's no pen thing. I have to be over in displaying this thing. Anyway, all right, so out here we refer to this array by the word people. But inside, so we pass that reference to an array through here as a argument to the show array method. And here's the show array method. We're defining a reference to a string array called str array, which is being passed in from this. So this now refers to Bill, Jill, Phil, and Will. See, this thing now refers to Bill, Jill, Phil, and Will. And so now inside here we refer to it as str array. So this does that for each loop where it loops through all the 4 elements of str array, and each time it goes through, you refer to that one element that we're on at the time as str. So str here is what you put inside for this argument to show the message box. Okay, so that's one way of passing an array. But down in here, geez, I sure wish there was a way I could write just. Wow, that kind of works. All right, Jill. Okay. All right. So that's one way. There's another way, and that's passing it. Well, this is here. You're passing it individually. Here, show people. Show people is the method, and it expects a single string value, a single string variable, and which it refers to down here. But up here where we call it, we actually are sending in an element of this people array, but that element is an integer. No, the element is well, it's declared someplace else as an integer. It must be a string array. People, was it declared back here? Oh, here it is. It's this one. So this is the same string array people, and here we're looping through, and this shows one people at a time, and so this shows one people at person. Should say person. All right. Okay, I guess we're done. Oh, actually, you are going to have to use this one for the assignment. Here, it's a sequential search, and we loop through because we're looking for something. And in the assignment, I want you to loop through to look for a name. All right, okay, so it's 11:35. I'm just gonna go over and explain the assignment so you can start thinking about that. So it's assignment 10. Now is when I want to use this edge. Assignments, assignment 10. So here's assignment 10. We start with assignment, we start with actually, okay, I said in the last two assignments, you started with tutorial 5.5 and added the following features and modifications. And you notice that this all takes you through assignment 8 and assignment 9, okay? So that's all this, assignment 8, assignment, that's not working, 8 and 9. That doesn't look very good. All right. But for assignment 10, I want you to do this. Store the names in an array upon initialization. Okay, so the array, so, you know, instead of just starting up, asking what the file is, and loading up the list box, okay, instead of doing that, you don't load up the list box, you load up the array. So now it's all in an array. And then I want you to modify the code, your code, so once the array is initialized, all references that were to the file are now to the array. So you remember in assignment 9, you're reading and writing the list box. No, in fact, you're reading and writing the file. You're reading and writing the file all the time, multiple times through the execution of a sitting. And what I'd like you to do is at the very beginning, you load up the array, and then all the times you're adding and deleting names or whatever, you're just doing it to the array. Make sure your code only reads the file once within the form onload event handler. And then I want you to put a button on there, a button that will save your array file should you choose to save it. So you're working along and you decide, oh, I better save my file, better save my work. So you click the save button and saves it for you. And then also, when the user exits and changes have been made since the last time it was saved, I want your program to ask whether you want to save your changes before exiting. So that means you have to keep track if changes were made since the last time the file was either read up or was saved. And so to make sure that works, I want you to add a label on your form which indicates whether the array has changed since you last wrote the file. So that means, you know, you click the save button, and that label is going to go blank or something. It's not going to display anything. But then you add a name, and then boom, the label will say, you know, file not saved or something like that. Or you delete a name. The label will say file not saved, and then so that way you give the user one last chance to save the changes when they click the exit button. If they click the little X or they click the red dot to stop it, you know, your stuff is not saved. Of course, there's a way to make it so it will, but that's a lot more complicated and beyond the scope of this course at this time. And then I want you to add a function to your program where the user can enter a name and click a button, and the program will say if the person is in the list or not. And if the person is in the list, it will return the index number. Okay, so, you know, let's say you have, you know, 100 friends in there, and you say, wait a minute, do I have a friend named Joe Schmo? I can't remember. My memory is failing me. So you type Joe Schmo, enter, and it'll say whether or not it's in there. All right, that's pretty easy. And of course, I'll do all these things in the next few days or so in one class or the other, do pieces of them. And then so if you, you can encourage you to try to figure this out yourself just by the lectures and the textbook. But if you can't, or search the web, find solutions that way. Encourage you to do that. But if all else fails, you're just going to have to sit through some of my boring lectures, and you can pick out all the parts that you need to do. All right, so now I want you to turn in the same stuff that I turned in before, form.cs1 file, form1.designer.cs file, screenshot of the program executing with your name in the upper right corner, and then I want you to do one more thing. I want you to add a 1-minute video showing your program, demonstrating your program running. And by the way, I will make versions of this video before you have to hand them in, okay? So like the next time or something, or maybe I'll make one. I should probably do this assignment to make sure that everything is nice and smooth. And I'll do it, and I'll make one for myself, okay? I'll make like I'm a student, and I'll submit the video, and that'll give you an idea. So it's just a minute, you know, a minute I can watch, you know. If it starts to get longer than a minute, I'm going to start saying, oh, it's going to take me too much time to grade all these things. So, so that's why you don't have to show me everything. Just sort of get used to this idea. I'm seeing if it works. I'm trying out these things, and I'm hopefully someday we can make online versions of these like these kinds of classes. So maybe by, I don't know, not 148, but 228 maybe. And then in the future, perhaps this class. Actually, I'm getting what's called what do they call it? A course equivalency or whatever it's called, course reduction or whatever. Where next semester I'm actually taking this workshop on how to make this class an online course, and it's this intensive eight week thing that's going to take up a lot of my time. But after that, then this course will be approved to be online, so that'll be kind of cool. But anyway, so I'm trying out a bunch of this stuff, these ideas, because you know, I tell you, I'll be honest with you, the last thing I want to do is to download your finished program and opening it up and clicking around. You know, it takes about 3 or 4 minutes to open up a new program that wasn't written on your computer, because it goes through all these checks and stuff, and that's just you know, really what I'm doing, what I'm looking for is I spot check these files here, and I can tell, you know, if everything works. And then this 1-minute video thing, I kind of want to see how useful it is, how well it works. So you know, it's probably going to be, you know, you do it or not, and then I just want to see you do it, and it'll see if you guys get comfortable. You don't have to have a camera. I don't need to see your face, but just you want to say a few words. Hi, this is Joe Schmo, and so first I'm going to run my program to show the existing names, and you run it. I'm going to add a new name, see a new name, test the name is in the list, test the name that's not in the list, and exit the program. And thank you, bye. So we'll see how that works. And so, so next time I will break out a finished assignment 9 and start adding some of these things. For assignment 11, I'm going to ask you to sort the list of names. But it'll be easy because we're able to do a really easy sort, because we're reading names in one at a time, and we're adding them to this array, and we can do it very easily because each time we add a new name, we position it in alphabetical order, and when you do it that way, it ends up being real simple. And so that way, now, as you know, as I'm sure you could guess, there's methods. The array method, the array class has got sorting methods in there, so you just say sort. But if you want to do something like, and this is what I'm going to do, I'm going to say, okay, I want you I want you to add the names to the array where you have the shortest name first and the longest name last. Okay, so the names are in order of the length of the name. Well, there's no built-in method, array method for that. You actually have to do a sorting technique. So it's a good algorithmic exercise for you, and it probably will be the most expansive brain-wise algorithm that you do so far this semester. It used to be that when we teach this class, we didn't teach any of this designer, text boxes. There were no text boxes. It was all, we started coding right away, and we would be, by now we would know the six common methods of sorting. There's like 6 common methods, and you'd learn the computational complexity of sorts and so on. By the time you're done with 228, you're going to know that stuff, but you're going to know also its relative importance with how it is today. And it used to be you did need to know about sorting, because if you had to have a sort in your program, you had to know what sort method to go find. You could probably find code to do it already, but you got to know the differences. Whereas now that's all taken care of by the integrated development environment. It's able to look at the context of your problem and choose the best sort method based on that. All right, so that's all I have today. Are there any questions? Yes. Oh, well, right now I'm using Zoom. That's a nice one. You can use, okay, so that's like an online one, but there's lots of, see, 1 minute, any free video software, any video software has free versions, and you can certainly record a minute. There's some things you might not be able to do, like zoom in, but I'm not asking you to do any of that stuff. And you're just recording the desktop too. Remember, you're just recording the desktop, not camera. You don't have to hook any of that stuff up. I don't need to embarrass you by seeing your picture. But I'll hear your voice. Like, I'll be able to tell your voices because I've heard you enough now. All right. Oh, if I just put MP4 because that's just so I can read it. So if it's whatever formats there are, and the Windows formats, and yes, that's fine. MOV is fine, of course. Yeah. Anything like that. All right. Okay. So thanks for watching.